For the first time in Russia, a cutting-edge material with outstanding properties has been created, the production of which until now was only available to the Japanese and Americans. What is this material, and what are the prospects for its use in the defense and civilian industries? We will tell you how the Oreshnik rocket's nose cone withstands enormous temperatures, as well as about other technologies and a new hero, after a brief summary of positive news. The Soyuz II-2A launch vehicle with the Progress MS-30 cargo spacecraft successfully launched from the Baikonur Cosmodrome. High Precision Complexes Holding delivered the first batch of TM-140 high-mobility snow and swamp vehicles to the Russian Ministry of Emergency Situations this year. A batch of serial PD-14 engines has been delivered for installation on import-substituted MC-21 aircraft. The upgraded engine for the Meteor 1-200R hydrofoil vessel has passed bench testing. The St. Petersburg tractor plant has started producing a pilot industrial batch of electronically controlled engines. A new airport terminal has opened in Novokuznetsk. The Stan Holding has started mass production of 5-axis computer numerical control machines for the aviation industry. In Saransk, serial production of agricultural machinery components has been launched. In Novosibirsk, components for UAVs are being produced. In Krasnogorsk, the first production facility in Russia for cryogranulated starter cultures has been opened. Scientists at Rosatom's research center have managed to produce carbon fiber with a strength of 7 gigapascals. First of all, only 3 companies in the world possess such technologies: the Japanese companies Toray and Mitsubishi Chemical, as well as an American company. And now so do we. This is an undeniable achievement based on the work of entire generations of Soviet and Russian chemists. Let us recall that carbon fiber is a high-tech composite material consisting of thin carbon threads combined with a polymer matrix. The threads have a crystalline structure oriented along the fiber axis, which gives the material unique properties. For example, with the same strength as steel, carbon fiber is 5 to 8 times lighter. At the same time, it does not rust, does not oxidize in water, is resistant to aggressive environments, withstands multiple load cycles without forming cracks, hardly expands, and does not create interference in the radio frequency range. Interest in carbon materials in our country arose in the 1960s during the space race, and of course, as a result of the Cold War. After all, we needed to reduce the weight of the warheads of ballistic missiles, and composites, for the reasons mentioned above, were perfect for this. November 15, 1988. The Energia launch vehicle put the Buran spacecraft into Earth orbit, which, after making 2 orbits around the Earth, landed at the Yubileyny airfield at the Baikonur Cosmodrome. At that time, few people knew that unique composite materials, special tiles made of ultra-thin quartz fiber, and other elements were used in Buran for the first time, protecting it from heating during re-entry into the atmosphere. It was proven in practice that the new materials could withstand temperatures over 1,500 degrees Celsius, and this was a huge achievement. The Soviet 4th-generation multi-role fighter MiG-29 contained about 7% composite materials in its structure. Quite impressive for the 80s. But despite all the undeniable achievements of Soviet science, we were forced to purchase raw materials for carbon fiber from Japan. The thing is, our own chemical industry was focused on mass-produced polymers, not on specialized materials, and domestic fiber was half as strong as the Japanese one. After the collapse of the Union of Soviet Socialist Republics, the situation sharply worsened. After the collapse of the Union of Soviet Socialist Republics, Russia inherited broken production chains. since many important factories ended up on the territory of the former Soviet republics. For example, one of the leading enterprises, Cherkasy Chemical Fiber Plant, as you can guess from the name, remained on the territory of Ukraine, where it was privatized, ruined, sold to foreigners for shopping centers, burned down, and then turned into a landfill. For a long time, we were forced to buy almost all carbon fiber from abroad. But first, the sanctions of 2014 and then those of 2022 put an end to this practice. Fortunately, we prepared for such a turn of events in advance and, under the guidance of Rosatom, began bringing together the remaining factories and research institutes as well as creating new ones. This work was not widely publicized, but the results did not take long to appear, and we became one of the few countries in the world to assemble a complete technological chain. From crude oil extraction to its processing into carbon fiber and final products made from it. You all remember how the Americans tried to disrupt the production of the Russian MS-21 aircraft by banning the supply of composite materials, but they only sped up the import substitution process. Today, all foreign composite components of the airliner have been replaced with Russian ones, and they account for 40% of the aircraft's weight. Composite parts are also used in the PD-14 engine, which is being mass-produced in Perm. In the design of the fifth-generation fighter jet Su-57, the share of composite materials is 25%. Military aviation has different requirements than civilian aviation, resulting in lower numbers compared to the MS-21. Composite elements are also used in Russian helicopters, drones, and of course missiles. If the thermal shield of Buran could withstand 1600 degrees, then the modern requirements for combat hypersonic missiles have increased significantly. The nose cones of the Zircon and Avangard missiles experience temperatures of over 2,500 degrees Celsius at certain stages of flight. Carbon fiber not only withstands such loads, but also maintains stability at speeds above Mach 10. Recently, Vladimir Putin said that the nose cone of the Aerospace missile system can withstand a temperature close to the surface temperature of the sun, which is 5,500 degrees Celsius. Let's be honest, only a limited circle of people knows what materials are used to achieve such a result, and they won't reveal those secrets. It's not metals, but a complex composition of materials like aluminum oxide fibers reinforced with silicon carbide and zirconium fibers in a carbon matrix. It's possible that, along with this, a coolant is supplied through microchannels into the structure of the fairing, and additional coatings and thermal insulation layers are also used. And this is truly a very complex and high-tech solution. But work is already underway on next-generation materials. In the future, carbon nanotubes will be woven into the fiber for a significant increase in strength, and microcapsules with refractory compounds will be added, literally healing microcracks. Graphene coatings also make composites electrically conductive, paving the way for the creation of so-called smart wings with built-in load sensors, for example, for airplanes. And additive technologies already make it possible to print the most sophisticated structures to improve their characteristics. So it's quite possible that soon even the properties of Hazel will be surpassed. But let's come back down to earth. Despite all the outstanding properties of carbon fiber, it has a significant limitation. It's high cost compared to steel. That's why it's especially important that we've mastered the entire production chain and achieved a strength of 7 gigapascals. After all, these materials also have extensive civilian applications. These include use in gas centrifuges for uranium enrichment, components of spacecraft, lightweight and durable prosthetics and implants, hydrogen cylinders, wind turbine blades, and other products. We can now make all of this ourselves from our own raw materials, and this is a huge industrial achievement that, unfortunately, the media has paid embarrassingly little attention to. Russia has made great progress in restoring its lost heritage, but there is still much work ahead. We will keep you updated on events in future episodes. Now let's discuss other technologies. Modern manufacturing is now unimaginable without computer numerical control machines or robotic manipulators. But sometimes, even if the machine is expensive and the control system is modern, it's still hard to get them to work together. To fix this situation, so-called post-processors are used, special programs that, figuratively speaking, explain to the machine exactly what the computer-aided manufacturing system wants from it. And such programs are created and configured by specialists with deep knowledge of the subject.